Hello everyone, this is a lecture from the Essential Calculus Problem series on the North Campus Calculus channel. In this series, we always solve exactly one calculus problem per video involving limits, derivatives, or integrals. In this lecture, I will solve the integral of cotangent to the power of 4x dx. In order to solve this problem, let's say the problem was the integral of cotangent to the power of 4x dx. To solve this problem, you should firstly remember that the derivative of cotangent x is equal to minus cosecant square of x. And if you don't remember this, you cannot solve the problem. Also, you should also remember that cotangent square of x is equal to cosecant square of x minus 1. If you do not remember both of these identities, you cannot solve this problem. First, if you do not remember the derivative of cotangent x, you should first rewrite the cotangent x cosine x over sine x and then take the derivative of it. You will get the minus cosecant square of x dx in order to remember it. Also, if you do not remember that cotangent square of x is equal to cosecant square of x minus 1, you should write cotangent square of x as cosine square of x or divided by sine square of x. We know that cosine square of x plus sine square of x is equal to 1. Then this means that cosine square of x is equal to 1 minus sine square of x. Here we can write here 1 minus sine square of x. Then the cotangent square of x becomes 1 minus sine square x over sine square of x. And this is equal to 1 over sine square of x minus sine square of x over sine square of x. We know that 1 over sine x is cosecant x. Then here we have 1 over sine square of x. And this is equal to cosecant square of x. And sine square of x divided by sine square of x is equal to 1. And this means that cotangent square of x is equal to cosecant square of x minus 1. And our important equations are these. Okay, I will erase them. Okay, we will use those two equations. And these equations are really important. You shouldn't forget them. In order to integrate cotangent square of x, cotangent to the power of x, we use the reduction method. Reduction means that to lower the exponent here. In order to do that, we will write cotangent to the power of 4x as cotangent square of x times cotangent square of x dx. And we know that cotangent square of x is equal to cosecant square of x minus 1. And here we will write cosecant square of x minus 1. And try to understand what I'm talking about here. Every time when we have an exponent of cotangent x, we use reduction. And always we use the same methods. And also for the, not only for the cotangent x, but also for the tangent x, we use the same method. I solved a few videos ago, I solved the integral of tangent to the power of 4x dx. And the method that I used at the other problem in the integral of tangent to the power of 4x dx was the same as I use here. Try to understand the links between these two functions, tangent x and cotangent x, also between secant x and cosecant x. If you understand the links between them, calculus will be more than easier than you think. Okay. Okay, we say cosecant square of x minus 1 instead of this. Then this integral becomes cotangent square of x times cosecant square of x minus 1 dx. Then we will multiply them. Cotangent square of x times cosecant square of x minus cotangent square of x dx. And we can split this into two different integrals. Then the integral becomes cotangent square of x times cosecant square of x dx minus integral of cotangent square of x dx. This integral is so easy that you cannot imagine. Okay, if you have a function and its derivative multiplied by dx, then you use substitution method. We know that the derivative of cotangent x is minus cosecant square of x, and we have here cosecant square of x multiplied by dx. Then this means that this integral is easy and should be solved using the substitution method. The exponent here is not important. This may be cotangent x, cotangent to the 5th power of x, or square root of cotangent x. It's not important because we have here its derivative multiplied by dx. And first we will solve this part, and second we will solve this part. Let's say our integral is cotangent square of x times cosecant square of x dx. If you understand how we solve this part, actually you can solve it from the mind without using any pencil, because after this method that I will tell you, you can see that this integral is equal to minus 1/3 times cotangent qx, and it's really easy. Okay, let's say cotangent x is equal to u. The derivative of here minus cosecant square of x times dx is equal to du. This means that cosecant square of x dx is equal to wink, take it here, wink, take it here, minus du. Then I will say this part du, and I will say this part u. And the integral becomes integral of u times minus du. Wow, minus du. You will say minus du here. And take this minus out of the integral du. And this will be minus, and since we have power 1, add 1 to the exponent, and this becomes 2, and divide the new by the new exponent. And the integral is minus 1 over, we have 2 as exponent here, then this is equal to u square. Okay, and when we integrate it, we add 1 to the exponent, and the exponent becomes 3, and we divide by the new exponent, and the integral becomes minus 1/3 times u to the power of 3. And since the u was cotangent x, the integral becomes minus 1/3 cotangent qx, and the integral is this. And let's come to the other part. I will take cotangent square of x dx and left behind this. Integral of cotangent square of x dx. Since the power here is 2, I cannot solve this integral. For that reason, I cannot reduce it, but I should write cotangent square of x as cosecant square of x minus 1. If you write this as cosecant square of x minus 1, you can easily solve the integral. And let's say it cosecant square of x minus 1 dx. Then we can split the integral into two parts, and this will become cosecant square of x dx minus 1 dx, but I don't need to write 1 here. Okay, we know that the derivative of cotangent x is minus cosecant square of x. Then the integral of cosecant square of x should be minus cotangent x, and this integral is minus cotangent x and minus the integral dx here is x. So okay, this is the second one. Then the integral was this. The integral was this. This was equal to minus 1 over 3 cotangent cube x and minus cotangent x minus x. Minus 1 over 3 cotangent cube x plus cotangent x plus x. And since the integral was an indefinite integral, we should add a constant. So the answer is this. And this was the fourth problem about cotangent x integral. And the next problem that I will solve in the next video will be cotangent to the power of 5x dx. See you in the next problem.